Hi, in this session we will be looking at how to use SCARA Robot for pick and place application. So let me go to the CoppeliaSim window. So when you open the CoppeliaSim software, this is what you see. On the model, in the model browser, you will see there are several libraries of existing models. So what we want is we want a mobile robot, we want a non-mobile robot, which is a, and we want a non-mobile robot, so where you will have several types of robot arms. We are looking for a SCARA robot. So here this is a SCARA robot. It is named as MTB robot. Okay. So when we run the simulation for this, we'll see there's already a script enabled for like demonstration of what this can do. So it's essentially picking up, placing these blocks. So let me stop the simulation and see let's have a look at the script which is used to move the box. So here's where the script associated with the object is, that's called a child script. So if you click on that, so you'll find these are just initialization and these are those initialization parameters. What we are mainly concerned about is the program which is used for running the robot arm. So here's where the program is, which is executed when you run the script. So if you see, it is setting the velocity, it is moving the arm to the 0, 0, 0. That's the joint values. So if you see, this is a 4 degree of freedom robot. So since it's a 4 degree of freedom robot, this is a joint, this is a joint, this is a linear actuator, and this is another revolute joint. Okay. So that's basically a brief of what software is happening. So let's run the simulation again and observe. So if you see the commands over here, it is asking to move to this position, move to this position. It is asking to wait, move to the position, right? So this is what the program is this is what the program is running for this arm. Okay. So now let's just quickly try to do it ourselves, right? Write our own code and have an individual joint control. So let me go ahead and remove all this parameters over here, all this lines of code, and just we'll have only single line. Okay. So what's happening here is that we are telling it, okay, the rotation velocity is 45 and linear velocity is 0. This is in meters per second and the rotation is in radians per second. So if I save this and run the script, basically what we'll observe is there's no movement happening. Okay, it's at the 0, 0 point. Okay, so if I'm running it, it has started. So there's no movement. Okay, because we are asking it to be staying at 0, 0, 0. So now let me move some joint, a particular joint. Let's say by first joint, that is this joint, by 90 degree. So I'll write 90 over there, 90, and we'll just stop and I'll run it. Okay. So you see there's a motion of 90 degree happening, right? So now let's say I make it minus 90. So and run it, so it will move on the other side. This is moving on the left hand side. Okay. So now let's just for the sake of observations, we'll also rotate the other joints. So let's say I'm moving the second joint by 90 degree. The third joint, remember, is not a rotation joint; it's a linear joint. So you have to give values in meters. Okay. So this both the joints are moving. Okay. So this command, this move command, is what is used to ask the robot to move to a particular joint value, and joint value are the angle and the distance, right? So now let's try to write a program for asking the robot to go left and go right. Okay. So how do we do that? Is we'll basically ask the robot to go left and right. So what you see over here is that we are initially telling it to go 0, 0, 0, then wait for some time. Okay. Then we are asking it to go 90 degree. Then we are asking it to go minus 90 degree. So left and right. So that's what we are that's what we'll observe. So it will go to left and go to right, and then it will stop. It will not do anything. Okay. So we'll just stop, run it, and see. So it's going to the right and now going to the left. You can stop, right? So now if you want to do this in loop, then what you can use is something called labels. So if you see REM, these are basically readmes. So these are basically comments. So when the code is executed or the program is executed, these lines will not be executed. Okay. So if you read here, it says like REM is for starting a comment line, this is for, so here the details are mentioned, right? Okay, so you can just go ahead and see what is what over here. What I was talking about was labels. You can use labels to loop it. So here you don't have while loop and for loop kind of thing, but here you can use labels to jump from one position to another. So let's say I write over here after this program in capital PROGRA program BE begin label, and at the end when after executing this thing I'm asking it to go to the beginning of the program again. Okay, so that's called go to program PROGRAM. I'll just copy this same thing and I'll paste it over here. Okay, so I'll save this and I'll run this thing. So if you'll see, now you'll observe it is rotating in loop. Okay, so you can also change the values over here. Let's say here I have defined it as some minus 43.5 something. I can just remove this and make it 0 or something. Okay, so that will be like more sharp. But that's up to you. Like these joint values are up to you. Whatever you want, you can have it. I'm just trying to show you what are the functions over here. Okay, so now this basically you have a bit understanding on how to how to move the command and how to jump around. That two are clear now, I think. Now next is how do we tell the robot when, let's say, this block is there, right? So let's say there will be a proximity sensor there, and that proximity sensor will tell, okay, now the block is here. Then only you go and pick. Oh, I have to tell you how to pick in place also, right? So there's something called set. So if you go back, so if you, let's say, if you do use a command called set and set a bit and clear a bit, then that will basically, a grip. The gripper you see, this is a vacuum gripper that will be enabled and disabled. So what you have to do is you have to use a set bit and a clear bit. So this basically, let's say I'm asking it to at the home position. Okay, at the home position it extends below by, let's say, 0.3. Okay, and at the so basically what happens here is it is at the home position 0000. Then it extends the linear actuator by 30 mm and then 30 centimeter. Then so I think so it would be 3 centimeter. For, this clearance is small, so let's see. Okay, then we enable the gripper, we engage the gripper. Okay, then we basically retract it back. So let's say we retract it back. So after extending, we retract it back. Then we ask it to go to, okay, let's wait for some time and go to the right position, and let's say we clear it. So after we clear it, we reach that position and clear it. So CLE clear bit 1. Okay, so you have to write 1 to. Okay, so let me remove all these other things now. So what we'll observe is that okay, I mistaken. See, clear bit 1. So what we'll observe now is that the robot will go to the home position, then it will extend below, it will extend the actuator, and then it will grip, then it will move back to the home position, retract the actuator, linear actuator, then it will go to the right hand side and then release the gripper. That's all the code is written, right? So so I have taught you another command now. So that is to grip. Okay, to grip and release. So that is for grip and release. So 3 commands which are crucial, now. Another thing is something called if bit to go to condition. So now how do we tell? So I'm coming back to the earlier point where I was saying, let's say we have a proximity sensor, and then only when the object is there, it has to go and pick and do some routine, right? Go to the left or go to the right. Those are basically a routine command to tell, okay, right with this instruction, left this instruction. So how do we tell the robot, okay, the proximity sensor has triggered, and now you ask the robot to go to do something. Okay, so there's something called input buffer. So if you see over here, there's this if bit go to Y label, it goes to a particular label when input buffer has a particular thing. So we have to write a value to this input buffer whenever the proximity sensor sees a value. Okay, so what you can do is you can have, so let's move to that part. I'll show how to integrate a proximity sensor with this and do it further. So let me close this and switch to the other part of the part 1. So this is where we'll be trying to add a proximity sensor here. Let me go ahead, add a proximity sensor. Let's say proximity sensor is here. Okay, retype. Okay, I'll just move it someplace. We don't necessarily want to, like, only when it detects. I'll go in that sophistication. For now, we just have the proximity sensor here. I'll just remove this. Don't worry about that. Okay. So in this proximity sensor, what you can do is you can add a child script. I'll add a child script, associated child script, and then I'll write the code. So for integrating, earlier I have done it with the full floor. This is just for context. I'm adding it for proximity sensor. It's not necessary. You can have the script anywhere. Okay. So let's now, how do we tell the robot to go to a particular left or right? That's what happens here. Okay. So if you see over here, the first part is robot handler. So if you recall, whenever you are trying to write a new script, first you have to tell what object you want to interface with, right? So you use the handler to interface to an object. So I'm having robot handler here. The name of the robot is MTB robot. So like MTB robot. Yeah. The name of the robot used in the script is MTB robot. So that's why it is MTB. Okay. Then this is the line which I use for. So if you see over here, this not this one, sorry. So if you run the simulation, there'll be internally a server will be running. So this is just for that. Like only when the robot server is on, then we execute the script further. So when the robot server is on, when the robot server is running, then we can interface. Then we can get the values. So remember I was talking about input buffer. So this basically using the robot server handler, we are getting the input buffer, and we are telling the input buffer to write some value. So this is we are physically writing we are explicitly writing a value over there. If you have a proximity sensor, based on that also you can do. So right now what I'm doing is to this input. So you can input buffer is like an array, and to that array, to the first position of the array, I'm writing value 1. So that is basically setting it to 1, and I'm telling the MTB to, okay, this is now the input buffer. Okay, so this is what the code is, and this is what the script is from the integration part of it. Now what we have it on the robot part of it, let's have a look at there. So if you see at the robot part, this is similar to what we have done earlier. What is different is that we have now used specific labels. So now if you look at over here, we have a label for for asking the robot to go to left. So what you see over here is, okay, it goes and extends the actuator, then then grips, then goes to this location. After going to that location, it goes back to the home position. Similarly, for the right, it goes plus 90. So like that. Okay. So these are the labels. So we have told, okay, this is one routine, routine to go left, routine to go right. Okay, this is routine to go right, this is routine to go left. Now the point where we say, okay, go to the left or go to the right is over here. So if input bit 1 is on, then it will go to the left. So if bit go to is 1 is on, then it will go to left. If go to 2 is on, then it will go to right. Okay, so this is the concept, and we have integrated this. So how are we getting this 1 and 2 value? Like how are the values written in this position? If you see, these are the position values, right? At what is the position of y. So at this position, the values are integrated over here. In the proximity sensor, I have written this, right? This part, right? So when it is 1, then it is going to the, so when it is 1, it will go to left or right, we'll check. Okay, I'll run it and show you. So when it is 1, it is going to let's say left, okay, and now it will always go to left because I have explicitly write value 1, okay, it will always go to left. Now let's say if I explicitly write value as 2, then let's say what happens, it will go to right, okay. So let me run it and show you. So this is explicitly going to the right, okay. So right. So remember, I am not using the proximity values for, I am just explicitly writing this just for, so you guys have to do, and in the next part I will show how to do the proximity sensor properly, okay. So if I, let's say if I don't have a value, if I just write as 0, so if I just don't write any value itself, right, whatever the input is, that's what I am saying, so there is no change. So if I just do that, then it will not move anything, right, it will not go to left or right because values are 0 in the input bit, okay. So if I just change it back, let's say Control Z. Okay, I'll write it again. Input equal to input 1 equal to input 1 or 1. Okay, so let's run and see if there's an error, we'll know. Okay, so we have asked it to go to left, right. So now let's try to do for the right. Okay. Okay, so right is going, right. So this is how you integrate with the proximity sensor, like not necessarily proximity, this is how you integrate with the other scripts and to interface the robot, okay. So how to give a like left or right instruction to the robot. So now let's look at the next part where we will actually integrate the proximity sensor and the vision sensor. So based on the color of the block, so it also decides, okay. So if it is yellow block, then it will go left, it's a blue block, then it will go right, like that decision it can make right now. So in that, so how it is now, the base code for MTB is the same, there's no change in that, only what I've made changes is in the proximity code. So what I've done is I've added the handler for the proximity sensor, I've added the handle for the vision sensor, then same as like you have to have the server running. When the server is running, we get the values from the proximity sensor, okay, values from proximity sensor we are getting, value from vision sensor we are getting, and we are also getting the input buffer from the MTB robot, okay. Now, only when there's some results, only when there's a value from the proximity sensor, only when there's an object over there, it will go in the loop. And this is essentially for latching. It's not super important to understand at this point. What is important is like this value. So you are reading the register, auxiliary value register of the vision sensor and seeing whether that value is yellow or blue, okay. If it's beyond a threshold, it's a yellow. If it's beyond it's a blue, like that, right? So based on that, we are telling it to go, like if you see this is the input buffer which I've written the code earlier, right? So we are telling it go to left or go to right, and based on whatever value we are getting from the vision sensor, right? And once that is done, if there's no sensor values, then we are just resetting it. So if you want to reset the input buffer, this is how you reset it. And at the end, you just write the value to the MTB robot. Okay. So let me just, this is the script. I'll just show the simulation also again. So let me run this, and let's see. I have to move this object now. Since the simulation is running, I have to move it physically because there is no conveyor system right now. So I'll physically move the object near over here. Okay. Since it's a blue, it has found this is blue. It is going to the left, right? And is stopping and placing it. Now it will wait for the other yellow block to be there, and okay, I just move the yellow block now. Let me select this and move this over there. Okay, so this is the second part where you are able to see with a vision sensor whether it's a blue box and a yellow box, and based on that you are able to distinguish. Okay, if it's a blue box, then let me put it on left. If it's a right, so I'll just quickly show the script on the robot end also. So it's just same as what was there last time, the same as that. Just some values might be different at joint values might be different, right? So this is for that. Now let me so I think that this covers all the things which you have to learn to try to attempt this problem statement. I'll just jump to the part which I'm expecting what you guys have to do and using this knowledge which you have learned right now. So the output finally, if you integrate everything, if you integrate a conveyor system, if you integrate the robot and do the pick and place operation, it should look something like this. So I'll just play the simulation. Yeah, so it goes, it detects, okay, it's a blue box, it's placing the blue box over here. So it's not this is left and right, but so you can tweak, like the questions ask for left and right. This one is for, let's say 180 degree and 90 degree, okay, something like that. But it's able to have a different position for blue box and yellow box, right, based on how it is detecting and moving. So that's how I'll conclude. What we have learned so far is basically how to integrate a SCARA robot how to integrate a SCARA robot and pick and place and do a pick and place operation with that. If you have any questions or any queries, you can feel free to ask that in the comments, and you can contact me anywhere, right? You can contact me on Facebook, you can contact me on LinkedIn, or just shoot me up an email, okay? So that's all, yeah.